pounds, 14-foot wingspan. First thing we did was some just rocket engine tests. Now, about this engine, you may be interested. Okay, here's the CO2 tank filled with liquid CO2. Here is the actual engine, which is really just a steel can filled with magnesium oxide pellets, which we wrapped with heat tape. He would heat it up to around 800 C, and then the CO2 is self-pressurized, it goes through here, and is ejected out the back to produce thrust. Now, the interesting thing that you see here, if you look at the exhaust temperature, is you'll notice, okay, the exhaust temperature, it goes initially it's cold and it jumps up to 700, and it pretty much stays there almost until the end of the burn. It's really a very gradual fall off. And you say, well, why should that be? Here I am, I'm cooling down these pellets by running cold CO2 through it. Why doesn't the temperature just go down linearly with time instead of more or less staying up as a plateau? And the reason is because what happens is when the CO2 comes into the pellet bed, it first encounters all these hot pellets. So it goes through the first layer of the pellet bed, coming through it this way, and it cools down, say, the first inch of the pellet bed, but then the CO2 is now hot, and it will not cool the rest of it downstream. So it just passes through the rest of the bed without cooling anything. And so it's hot. Now the next bit of CO2 comes in. It passes through the first inch of the pellet bed, which is cold, without being heated. But then it encounters the second, which is hot. That heats it up to temperature, cooling down the second inch, but now it's hot and it won't do anything to the rest of the bed. So basically, until almost all the bed has been cooled, the CO2 comes out at full temperature. That's how this goes. So the performance is maintained through the length of the burn. Of course, once all the bed material has been cooled, then it no longer can function. But until that happens, it functions almost at full performance. So after testing the thing on a test stand by itself, the next thing we did was put it on a go-kart and made a rocket car. And this was useful, both to have the discipline of making it into a mobile system instead of a test stand kind of thing. This go-kart had been rated for 25 miles an hour, but we got it up to 40. There you go. This is actually one of the safest rockets you can build because there's no chemistry going on. You can't have any explosions or anything. All right, so then we started developing the aircraft, and we did this the right way with real NACA airfoils and all this stuff. And, pretty sophisticated fabrication job was done. We were interested in lithium fluoride crystals for a while because it has very high specific heat. And we did some experiments with it. But the problem with lithium fluoride is so long as you keep it below its melting point, which is 860 C, which in principle we could do because we were only going for 800 C, it's fine. It's solid and it doesn't corrode anything. But as soon as it gets above its melting point, it becomes a liquid salt. It becomes very corrosive. It can eat its way right through steel and even many ceramic materials. And so we didn't want to have to worry about, are we over the line? And, we just wanted to get something that would work. And so we stuck with the magnesium oxide. Now, at the same time working on the airplane, we're also working on the vertical takeoff vehicle, which we started off with just what we call a flying cross, which was a crucifix with thrusters in the corners, and it would try to keep itself stable with an automatic feedback system on the little thrusters. And then we put it on something that closely resembles a vehicle that had to balance itself on a point, basically, this without tipping over with the feedback. Now, the thing with the vertical takeoff vehicle is stability is much more complicated. And that's what we have to master. Okay, and then we actually built a vertical takeoff vehicle. And you can see here that there is no tension in that. There's a safety line attached to it. That is hovering right now. It has a main thruster here that's actually exerting the physical force that is holding it off the ground. And then there's balancing thrusters on the ends of the booms, little thrusters, to keep it balanced. And we had this safety line on it so it wouldn't just fly away. Although subsequently it did cause a problem, as you will see. It flew to the edge of the line, and the line pulled it back and crashed it there. But you can see it did take off vertically and maintain some stability for a while. Then, to get some flying experience, we built a small Gashopper engine, and we put it in an RC aircraft. I forget the exact model number, but this is a fairly popular little RC aircraft, had a wingspan of, I don't know, 3.5 feet or so. And we took out the gasoline engine and its tank, and we put in a Gashopper engine. And in this case, we had the thruster go out the front, and then the pipe went this way and this way. So it kind of looked like a propeller of the exhaust from the engine coming out frontwise, the pipes going this way and then pointing backwards. But it wasn't a propeller, it was just a rocket thruster. And we flew this, including maneuvers. The sound's not working. Okay. Here we're doing a 360. By the way, when you do these things with these RC aircraft, it's very important to have a good RC aircraft pilot because we lost some early models not due to defects in the propulsion system, but just due to bad piloting. And it's quite a skill. But now then, we finally completed the large Gashopper airplane, and here it is, flying. And so it has a wingspan of around 14 feet, and it weighs about 120 pounds. And thrust was 90-pound thrusts. First we did taxi, then touch and go, take off and just touch, and then finally some flights. So here's a video of one of the flights. We're controlling it from that car. I'm driving the car, and then the RC pilot's got his head up through the sunroof. And we could almost keep up because the aircraft was only flying about 70 miles an hour. Here's another view. This is from the camera that was actually on the aircraft. Telling it to them. Get off or on. Now it's actually the warning to the various ground spotters.